what does absolute value mean? So, yeah, Paige? Yes. Okay. The absolute value is not defined as it makes things positive, right? That's not the definition. That's what absolute value does. But what the absolute value fundamentally is, what it's defined to be, is the distance of a number from 0 on a number line. Okay? Okay. Can a distance be negative? No, right? And so that's why when we take the absolute value of something, our results end up being positive, right? When you take the absolute value of some value, some number, okay, your result's positive because you're talking about its distance from 0, and that distance will not be negative, it'll be positive, right? You don't really, a negative distance doesn't really make sense in context, okay? You may remember, so there's a way to actually define absolute value function, right? So, of course, the absolute value function, we draw it or symbolize it, right, with these two like vertical bars there, right, next to x. And so that's like our parent function there, the absolute value of x. Okay. We can further define this using a piecewise function. You might remember the word piecewise, okay, back from Algebra 1, okay, where you had to like graph like parts of different functions together on the same graph and make like one new function with that. All right, we're going to just dip our toes into piecewise for right now, but it will be a topic that comes up again in the future, okay? So if piecewise, kind of makes you sweat a little bit, well, that's okay. We'll get some more practice in and stuff, okay? So piecewise functions typically have like that big brace there, and you have a couple of different functions. So the absolute value of x will be equal to just x for x values that are greater than or equal to 0, we'll say. Okay. So the absolute value function as a piecewise function will be the same as just plain old x, right? Where x value is greater than or equal to 0, which makes sense, right? If your x value is greater than or equal to 0, then that means it's positive or 0, and so then your function will be the same thing as whatever that x value is. And it'll be equal to negative x for x values that are less than 0. Okay. So, like hypothetically here, say you wanted to find, absolute value of positive 2. Right? Absolute value of positive 2. Well, since the x value is 2, right, we're going to use this top part of the piecewise function, right? Because 2 as an x value is bigger than 0. And so the result is going to be 2, the x value of 2. Okay? But if I try to do the absolute value of negative 3, okay, which part of my piecewise function will I use now? The bottom, right? Because negative 3 as an x value, right? The negative 3 as an x value is less than 0. So that means we're going to use this part of the piecewise function. So since my x value is negative 3, I'll now have a negative 3. And what's negative 3? Positive 3. So it makes it positive 3. So you see it works, right? So this is another way to define the absolute value function, right? Another way to define it using piecewise. Okay? If you, well, maybe I'll hold off on that. Yeah, so just, there's the piecewise stuff. All right, so I've got something for you guys to do here. So I want you to finish the table. And use the results to graph f of x equal to the absolute value of x. And again, you can feel free to do this graph on the graph paper that I just gave you, or like the little grids and stuff like that. Or you can just sketch it in your notes too, because it's not too crazy. It shouldn't be that awful. Okay, so that's what I want you to number 1. All right, and then once you finish the table and graph the function f of x equal to the absolute value of x, I want you to ID for f of x. Okay, for the absolute value there. Identify domain, range, max, min, zeros, increasing, decreasing, constant, and behavior, and even, odd, neither. Okay? So here's a table I want you to fill out. Ready? Easy peasy. So, x values, -2, -1, 0, 1, and 2. Give me the matching y values there when you plug them into absolute value of x. Plot those points, connect them right to make the graph, and then give me all this. Give me all that. Tell me the domain, tell me the range. Tell me the max, the mins, the zeros, any intervals of increasing, decreasing, or constant. The end behavior, if there's any, right, and an even, odd, or neither, right, if that's your function there. Okay? Go ahead. Take a few minutes and do that. If you want to use your graphing calculators to help you, feel free. That's an available option. I'll kind of come around and answer any questions. Right, so absolute value does not just make it.
So it would just be that?
Yep.
Okay, I'm going to do that.
Maybe like 1 or 2 more minutes. Bless you. One or 2 more minutes. So, right, I see what you're saying. Yeah, so, yes. I hear what you're saying, though, because I only went from -2 to 2. I see what you're saying. That's a good thing there. But yes, I'm okay with you continuing on here. I just want to get the whole graph, basically. I didn't mean to limit the domain. Yeah, just so you guys know, I didn't mean to just limit the domain from -2 to 2. Please continue the graph. That's okay. Yeah. And then, of course, identify the domain range based off of that. Yes. Yes. Sorry, that's good. I did not mean to limit the domain. Thank you guys for thinking about that stuff, though. That's good. I like that you're asking those kind of questions and stuff. Making those considerations. Okay. Let's see how we did here. So, I kind of spoiled it for you. All right, there's the table filled in, there's the graph. All right, you might have already had an idea of what it looks like in your head just from, remembering and stuff like that. But let's review some of these very important characteristics, right? All right, so Brady, help us out here. What is the domain? All real numbers, yeah. So you can put the real number symbol if you want to. I'm going to put -infinity to infinity like this. Okay, an integral notation there. Very good. All right, how about, let's go to Cameron. What's the range here, Cameron? 0 to infinity, very good. Okay, and of course, always a parenthesis with the infinity, but what about the 0? Should I get a parenthesis or a bracket? Yeah, very good. We get there. You got it. Okay. Thank you, Cameron. Let's go to Megan F again. Megan F, do we have a maximum here?
I just said y equals infinity.
Right. So in other words, there isn't a maximum here because it just goes on forever. Okay. So if you put infinity, I understand, but I would actually like you to put that there isn't one here. Okay. Because the idea of a maximum is that you have a highest point. Right? If you're going to infinity, you're going to continue to increase without bounds, right? A maximum indicates some sort of boundary, the highest point. There is no the highest point because it keeps going on. Okay? So, yeah, thank you, Megan. All right, let's go to Jonathan. What do you say about the minimum here, Jonathan? 0, okay? Very good. Yeah, so you can give me the coordinate 0, 0 if you want to, but y equals 0 is fine as well. So that's okay. That is the absolute lowest point there. Very good. John, you want to also tell us what are the zeros of this function? 0 again. Hey, look at that. Yeah. We just have 1 0 at 0, 0. Okay. Or you could also say or x equals 0 if you like. Okay. Very good. Thank you, John. All right, let's go to Karina. How about, is this function ever increasing, Karina? Yes. Okay, what x value would start increasing? 0. And then it increases further to the right all the way to what? Infinity. You got it. Okay, so 0 to infinity. That's right. Good job. Thank you, Karina. Let's go to Paige. How about decreasing here, Paige? Very good. -infinity to 0 in the correct order and stuff too. So, yep, we are decreasing. Okay. Let's see here. Aiden, are we ever constant? Yeah, so never. So NA or never, or whatever you want to put there, that's fine, not applicable. Okay, something like that. End behavior. Okay, so remember the end behavior, right? What does end behavior mean? It's what happens at the ends. What happens as you go really, really far to the right, which is x approaching positive infinity. What happens as you go really, really far to the left, x approaching negative infinity. Okay, right? So let's go to Jordan. As x approaches infinity, f of x does what?
Goes up to infinity.
Yep. And as x goes to negative infinity, f of x goes to?
Infinity.
Infinity. Okay, question now.
Yeah, for the range, you put 0 in a bracket, but why is all the other ones, all the other zeros in parentheses?
So for like the minimum, okay, so y equals 0, I would consider that to be like a bracket in some sense, right, because you're like equaling 0 there. But then this is a coordinate, that's why I have it in parentheses there, I'm listing it as like a point. And then same thing here, this 0, I'm listing it as a coordinate, so that's why, it's 0. For increasing and decreasing, you can include the zeros if you want to, but here's my concern, right? So let's say we put a bracket with this 0 and a bracket with this 0. That means we'd be including 0, increasing and decreasing. In my opinion, right, it doesn't really make sense to say that 0 is you're increasing and decreasing at the same point. But it can depend on how you kind of define increasing and decreasing. I will always exclude it, but if you happen to include the endpoints on increasing and decreasing, I shouldn't count it against you. I'm trying to think if there's like a place where it should be obvious that you don't include it, but if you happen to include them, I don't think I should count it against you. So feel free to hold me accountable to that if I make that error on a quiz or a test. Okay. So, last thing here. Is it even? Is it odd? Or is it neither? No. Even. Yes. Okay. So we are even here. Okay. All of our absolute value functions should have a line of symmetry, also known as the axis of symmetry. Okay, and in this case, the axis of symmetry is just the line, x equals 0. Okay, so that's another little aspect that we bring in here, unique to absolute value, and you see the quadratics too, axis symmetry there. Okay, so you should also, so this is a new thing that we should be able to identify too. Well, it's not like new though, because we've seen that in parabolas back in Algebra 1 and stuff like that. So we also have an axis of symmetry here in absolute value. Okay, questions on any of that? So I'm not going to do this for every problem we do today. I'm doing it for just this one right now. But you should be able to do this for any of the problems that we do today, right? I should be able to ask you these kind of questions, and you should be able to come up with them accurately. Okay? So, just a heads up there. Any questions, though, before we move on and get to some more graphing? We're all good? Okay, let's try another one here. So, I'm going to kind of move over to the graph paper here, so that way we can kind of just get to the graphing part. All right, so I'll just go ahead and use this second cell here. All right, and let's just say we're going to do another example here, and let's say we're going to graph g of x equal to the absolute value of x plus 3 plus 1, like so. Oh, one other little thing I wanted to point out here, too. I forgot to do it. Okay, you can see here that the absolute value is kind of made up of two lines, right? This is a line, right? It's a linear equation. What's the slope of this linear equation? What's the rise over the line? 1, right? What's the y-intercept of this line? 0. So there's that piecewise piece, right? Slope is 1. Plus 0, right? There's no 0, there's no number there, so plus 0. So 1x plus 0, there's that piece right there. Okay. What's the slope of this line? -1, right? And what's the y-intercept of this line? 0. And there's the other piece of our piecewise function. -1x, right? And then you can put a plus 0 in there. Okay? So what is an absolute value function? It's just two linear equations, two parts of a linear equation. One equation that's positive x, one that's just negative x. Okay? So I just wanted to point that out. Anyway, sorry. Back to this. All right, now we see this function. And hopefully this should look familiar to us from some of the transformation stuff we've been talking about. Okay? what kind of transformations are happening to the absolute value of x here for our parent function? So page left 3 and up 1. Exactly right. Okay. So left 3. Okay. Up 1. I wrote that very small. Let me zoom in on that. Sorry. Okay. So if we look over here at our original graph, right, we have this point where the two lines kind of intersect down here at the origin. Okay, that point is called the vertex. The vertex, right? So we're going to transform that vertex first. Okay, so we're going to transform the vertex. So normally our vertex would be right here. Okay, but we're going to shift things. I guess we'll do this like in red or something like that. Do I have a red idea? Okay, so we're going to go left 3, up 1, and there's where our new vertex is going to be. Okay, right there. Left 3, up 1. Okay. Now, did our graph do any sort of vertical stretching or shrinking? No. So from this point, if I want to get more points, I can do the exact same kind of relationship I see here, where I went up 1, right 1, up 1, right 1, up 1, right 1, because we didn't stretch or shrink it at all, so it's still going to have that same kind of slope. So just up 1, right 1, 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 up 1, right 1. And to get the other side, you could use symmetry, or you can just kind of, see we're going up 1, left 1, up 1, left 1, right? So just then go from there. Easy peasy, right? So there it is, transformed. All right, questions on any of that? All right, so let's do one with an actual stretch too. Let's do one with a stretch as well. All right, so I'm going to go, I'll zoom out some here, and we'll go down to this guy right here. Do we have a vertical shift here? Vertical shift. No vertical shift. Do we have a horizontal shift?
Yes.
Yes. How much and which way?
1 to the right.
1 to the right, right? Yeah, right 1. Okay, that minus 1 in with the x, right, shifts it right 1. That 2 in front is going to do something. What kind of transformation is that? So, click. 2. Yeah, that's right. Yeah, 2. Okay. 2. Vertical stretch of 2. Vertical stretch of 2. All right, so how are we going to handle this? Remember that we're going to kind of do the stretch first, okay? So all of our y coordinates then, so in our original function, right, we went up 1, right 1. So now we're going to stretch everything by 2. Instead of going up 1, right 1, we're going to go up 2, and then right 1, because we're only stretching vertically here. So we're going to go up 2, right 1. So in other words, this 2 is like the slope, right? It's like we're going up 2, right 1, right? If you put this as a fraction, 2 over 1, it'll be rise of 2, run of 1. It's literally the slope, okay? So, but of course we have to make sure we shift right 1 first. So we're going to go right, we're going to show the right 1 shift. So there's our new vertex, okay? I just said right 1 and then drew left 1. All right, here is our new vertex. All right, and now we'll use our slope. So up 2, right 1, up 2, right 1, up 2, right 1, and then same thing symmetry-wise. Okay. Okay. And so there it is. Shifted right 1, and then slope of 2. let me give you what guys want here to try. Oh, first, before I do that, is this an even function? But it's got a line of symmetry right here, right? I can fold that, it's symmetric.
But it's not on the 0.
Right. Okay. The line of symmetry is not the y-axis. This is not an even function. Okay. Is this an even function? No. Okay. Again, it has a line of symmetry, right? The axis of symmetry would be x equals -3 here, right? Axis of symmetry at x equals -3, not even because the axis of symmetry is not the y-axis. Okay. So be careful there. All right. Here's one for y'all to try. Y equals 7/3, absolute value x plus 2 minus 6.
Can I go to the back?
Yeah. Okay, so what kind of transformations do we have here? Our vertex we have to shift which way? Left 2, down 6. So 1, 2, 3, 4, 5, 6. Okay, and then our vertical stretch here is, it was a 7/3, right? So again, we would have stretched it 7/3. So instead of going up 1, we would go up 7/3 and then right 1. Well, that's kind of hard to do. But again, you can treat this like it is a slope. So we can literally just count from here, go up 1, 2, 3, 4, 5, 6, 7, and then right 1, 2, 3, and there is a point. Okay, and then by symmetry, we can go up 7 and then left 1, 2, 3, and there is another point. Okay, and that allows us to graph this with relative ease, right? And so you can kind of connect those dots. I don't think I have enough space yet. I don't have enough space to put the rest of it on there. So again, because we're essentially graphing lines, this number in front, okay, is like the slope. Okay, 1 is the positive version, so positive 7/3, and then we're going to graph a negative 7/3 version too. Okay, and that gives us our equation. Question on any of that? All right. So what about this? Because not only do I want you to have a function and graph it, I want you to be able to have a graph and function it. So like write it as a function. Okay. So I try to make it very bold here. There's the vertex. There are some points, okay, that are for sure grid points. Okay. So what kind of transformations do we see here? I can zoom in some more if you need to. Not if that's better or worse. What kind of transformations do we see? So yeah, go ahead, Troy.
So you go up 5.
Okay, so up 5, all right. And also what else?
Left 3.
Left 3. So that'll be absolute value. If we want to go left 3, I'm going to do x plus 3, right? And then that 5, going up 5, what will I put out here? Plus 5, right? Whoops, I'm off the screen. There we go. Sorry about that. Okay. What number is going to be out front here, though? I have to get from this point to this point, right? So how can we get from here down to here? How do I have to move? So yeah, so down 1, 2, 3, 4, 5, and then right 2. And counting that -5/2 also takes into account that we have a reflection, right? It's not opening up anymore. That V is now opening downwards, right? That kind of V shape that we have here. And so then that -5/2 takes care of that, okay? So the negative shows the upside down part of it, right? And then the 5/2 gives us the correct slope to get to the next points and stuff. Okay, and so there's our function. I'll say h of x there. Okay. So yeah, we had to go up 5. Left 3, and then that slope there. Okay. Okay. Questions on any of that? Yeah. Yes. No questions? All right. I got one more thing I want to show you here because, well, yeah. Okay. This last little piece here. So I told you that that b parameter, the parameter b that can show up in front of our x but inside the function, okay, I told you that we weren't going to worry about that for most of the functions that we're starting out with here because we can manipulate things around, right? But then here I am showing you that b in front of your x, and you said we weren't going to look at this, Mr. Wayne. Well, yes, but let me just show you. So what we're going to do here is we're going to remove this b from in front of the x. And the way we're going to do that is by factoring b, okay, or factoring from the grouping kind of inside here. So we're going to factor that b out. Okay. Now, I have a positive 2 here inside the absolute value. So if I pull that positive 2 outside the absolute value, what would that become? 2 still, right? So yeah, this will still be then 2, but now I can put it on the outside. The x plus 2 remains on the inside, and then the plus 1. Okay? So this is how we can handle a b value showing up in our function that we want to graph. We'll just factor the b value out, so the 2 there, which means it also affects that 4. Okay? The 2 then we pull it out front, making absolute value 2, which is just 2. And you can see here the shift is actually left 2 and up 1, not left 4. So be careful. That b value affects your horizontal transformation there, okay? Your horizontal shift. So factor the 2 out first so that you can pull it out front. And then now you can see your horizontal translation is -2, so go to the left, and then up 1, and then stretch it 2. Okay, I'll leave that to you to graph it there if you want to, or I'll do it here real quick if you want to see it. All right, because I want to get you guys started on your assignment, give you time to work on it here in class, finally, okay, because I know that's something that I'd like to try to do, and I really apologize for not being able to give you guys a lot of time to work on your homework in class. So I'm trying to rectify that now. All right, so on page 54, which is section 2.1. Okay. We will have you do numbers. Seven, 8, 9. Actually, let me just do it this way. 7 to 9. And 12 to 14. And for 12 to 14, please use y equals a parentheses x minus h plus k form. Don't use a b value there. Just use the a. Okay, ignore what it says. Just use this form. Okay, for all three of those. Well, it's really for 13, 12 and 13. But anyway. Yeah, okay. And then 18 through 20. Okay, so 7 to 9, 12 to 14, 18 to 20. Okay. And if you're still having trouble accessing your online textbook, let me know and I'll come around and help you with that. I have a few spare Chromebooks here too if you don't have a Chromebook with you. All right, so yeah. So we can get knocked out here. Okay. I'll try and work on having a few physical copies of the book in here too for you guys. Let me go ahead and do this too. Would anyone like a physical copy of the book to take home? Anyone want a physical copy? Okay, so Megan. Okay, anyone else? All right. So, oops, that's the wrong thing. All right, Paige, you'd like one. Okay, very good. Okay, gotcha there. Tim, gotcha. Thank you, Tim. Anyone else? Yes. All right. Ash, you want one? Yes. Yep. Go ahead. Here, let me get this. Actually, grab one of those 3 because that one doesn't have a charger with it. So yeah, maybe just put the paperback, please. Thank you. All right. Anyone? Oh, you two as well. Gotcha. So Jordan. Okay. Very good. All right. And you want one too? Yes. All right. Gotcha. Thank you very much. Very good. Anyone else that wants a book? Anyone else want a book? Okay. So I'll make sure I'll try and get one for you guys then for tomorrow and stuff, so you can have one. You can take it home and keep it at home too if you want, or if you want to carry it around, that's your choice too. It's not the green one; it's a blue one. Yeah, so yeah, it's a different book. I was originally going to go with the green one. That's why you see 2 in there because there was one for your class and one for another class. But then I don't know. Yeah, and now I'm just being lazy and not moving them because it was yeah.